Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about inference for sampling. All right, so a simple random sample, or abbreviated SRS, is a sample chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. Sampling variability is the fact that different random samples of the same size from the same population will produce different estimates. All right, another important thing to note is that increasing the sample size does not reduce bias. So if you collected your data in a using a biased method, even if you take a larger sample, it's still going to be biased. All right, an example of selecting a simple random sample. A safety engineer at an automobile assembly plant knows that 180 pickup trucks will be assembled tomorrow. To meet federal regulation, the engineer must select 5 of those vehicles for safety testing. Describe how to select an SRS of 5 trucks using slips of paper. All right, so we could assign each truck a unique number from 1 to 180. Write the numbers 1 to 180 on identical slips of paper. Put them in a bag, shake the bag, select 5 slips of paper, and test the trucks that were assigned those matching numbers. All right, and we would want to take those pieces of paper out without replacement, meaning we're not going to put them back in the bag. Describe how to select a simple random sample of 5 trucks using a random number generator. All right, so again, I would assign each truck a unique integer from 1 to 180, randomly generate 5 integers from 1 to 180, ignoring repeats, and then I would test the 5 trucks that were assigned those generated integers. All right, an example of sample variability. A recent Gallup poll found that 55.7% of a random sample of 1,947,144 Americans eat produce often. For the purpose of this poll, eating produce often is defined as eating the recommended daily allowance of fruits and vegetables at least 4 days in the previous week. Do you think that the percentage of all Americans who eat produce often is equal to 57.7%? Explain your reasoning. All right, so we're going to say no because different random samples will produce different estimated percentages. It is unlikely that this particular sample provides a percentage that is the exact correct answer. Okay, it's probably somewhere close to 57%, but that was just from one sample. If I did another sample of that same size, I would still get a different value, most likely. If the sample size was decreased to 10,000 Americans, what effect would this have on the estimated percentage of Americans who eat produce frequently? So the estimate is more likely to be far from the true percentage of all Americans who eat produce regularly. So as I increase my sample size, I get closer to the true value. Okay, if I take a larger sample, it's going to get more accurate results. Inference for sampling. The purpose of a sample is to give us information about a larger population. The process of drawing conclusions about a population based on sample data is called inference because we infer information about the population from what we know from the sample. All right, testing a claim. Do people prefer the last thing they taste? Researchers at the University of Michigan designed a study to find out. The researchers gave 22 students 5 different Hershey Kisses: milk chocolate, dark chocolate, cream, caramel, and almond, in a random order and asked students to rate each one. Participants were not told how many kisses they would taste. However, when the 5th and final kiss was presented, participants were informed that it would be their last one. Of the 22 students, 14, 64%, gave the final kiss the highest rating. This is greater than 20%, the expected percentage if people don't have special preference for the last thing they taste. To determine if the data provided convincing evidence that more than 20% of students like these prefer the last kiss they taste, 100 simulated simple random samples were selected. Each dot in the graph shows the simulated number of students out of 22 who prefer the last kiss, assuming each student had a 20% chance of choosing the last kiss. Explain how the graph illustrates the concept of sampling variability. So, if the researchers take many samples of size 22 from the population of students who show no preference for what they taste last, the number of students in a sample who prefer the last kiss varies from about 1 to 10. All right, part B. In the simulation, what percent of samples resulted in 14 or more students preferring the last kiss? All right, so 0 out of 100. 0% of the simulated samples resulted in 14 or more students preferring the last kiss. In the actual study, 14 students preferred the last kiss. Based on the answer to part B, is there convincing evidence that the students like these prefer the last kiss they taste? Explain your reasoning. So, because it is unlikely to get 14 or more students who prefer the last kiss by chance alone, there is convincing evidence that students like these prefer the last thing they taste. All right, go Seahawks.